What's up YouTube? This is Jacob from International Precision Engineering, and as you can see we have the smart car here in the garage, and the plan is to fit a winch to the front of it. So in case you're wondering why we're putting a winch on a smart car, we are taking this to the Baja 1000 in November, so it's about a month away. And we've got the bikes lined up, but Doc says I can't ride them. So better off listening. So rather than taking the SUV, which we really don't need, I'll be driving this. The Baja 1000 this year is all off of the highway pretty much. It kind of drops down to Rosarito from Ensenada and then comes back. So rather than taking SUVs and trucks and all sorts of stuff, this is fine. This is all we need. So it's medical supplies, fuel for the bikes, radios. You don't need an F350. You know, we're not racing, so we're just going down to spectate. So this is all we need. When you're in the Baja, not so much for the Baja 1000, but if you get off the trail, it's really difficult to see where the pack ground ends and where sand starts. So you could be driving along and all of a sudden, especially with pizza cutters like this thing has, the car will just dive into the sand. You know, it'll start squashing left and right, but before you know it, you're gonna get stuck. So even though this has traction control, which applies the brakes to either back wheel that's slipping, if it digs in, you're kind of SOL. And it's not like you can call a tow truck. You're out there by yourself. So we'll have multiple spares, we'll have the winch, and we'll be carrying stuff like fuel for the bikes or medical supplies, whatever. So it's really just a chase vehicle, and rather than taking an SUV that if you get that stuck, you're really screwed, we'll just be rocking this. So this is all we need. Let me bring you in close up on the winch and we'll get going. Alright, so we got the car up on jack stands. We've got all the plastic pulled off, which on a smart car means the side skirts, bunch of things on the doors, end caps on the mirrors, unclip all the body panels on the bottom, and then this front bumper cover comes off. So we got all that off and it's just sitting on here right now, not bolted on. We popped the grill off while the bumper was off and decided that this is where we want the winch. And it fits decent in here. It was a toss-up between the top and bottom of the grill. I think the bottom's fine, and you say like, oh, what if you hit a pile of sand or something? But if you look at the angle from the tires to the winch, I mean, that's not what we're doing with this, and this will be fine. And even still, if this catches and bends the bumper, so what? The problem is the purpose is just to pull us out when we need it, and even if it gets hit, the only precaution that we have to take is these mounting bolts. There's one on the front and one on the back on this winch, and if this does get hit or twist or turn, it's going to punch a hole right into our AC condenser, and that's not what we want. Alright, so what we've done here with the bumper cover just resting on the frame, I mean, it's pretty much where it's going to be. You can tell it can't move, but it's not bolted on. And we've got the winch set in there. None of the bolts are tight, and it's really kind of just sitting there resting on the screwdriver. But the important thing is that we have to go through and take measurements to find out where this is going to sit so that we can start making brackets without the bumper cover on, right? With the bumper cover off, we can really see where the steel is and where all this stuff kind of goes and what's behind here, like this vacuum hose. And we just take a piece of scrap aluminum, and with this ATV winch, there's only 2 holes on the winch, and there's a bunch of holes in this winch plate here, this black piece that essentially connects the winch to the fairlead here. And I think all that I'm going to do is cut this plate to basically stand it up like this. We'll tap the winch in right from the bottom, and then put 3 holes in this bumper, one on this flange, one on this flange, and one here. So the difference between the 2 flanges and this will lock the bumper from flexing like this but it won't stop it from torquing. But you know, our connections are here and here, and our winch is here, and this is some pretty thick stuff. And again, we're not hanging the car on this, although I probably think you could. So I think what I'm going to do is pull the winch out. We'll cut the aluminum piece to fit behind the bumper. We'll get our holes drilled, and what I'll probably end up doing is taking this right off and doing it right on the mill, so that I can really get some pressure and not destroy my drill bits. The challenge here is that this piece of scrap aluminum has these holes here, so when we go to drill our hole here, we don't want to end up tapping into one of these holes. So that's really our only precaution. And then what'll end up happening is once we get that fitted and where it can bolt on, I have the measurements from this air dam up to the top plate, so all we can do is we take the winch right out. We'll measure with this bolted on, we'll measure up, we'll scribe our line, saw it. And again, the tolerance on this is probably a couple millimeters, so it doesn't really matter, and we can almost eyeball everything with basic rulers and measurements and scribes and things. And then once that's done, once that's cut to where the top plate fits flush to that, then we'll mark where our holes are for the actual winch, and then we'll go and then tap them all right from the bottom. We took the bumper off, we drilled our holes on the mill, but didn't clamp it down or anything, so it was basically like a drill press. Then I just took, while it was off, it was real easy to make a cardboard template to fit the profile, and really the only places that need to be close are the 3 holes. So I'm going to do again one on the flange, one on the top and bottom flange, and then one in the center. So what that'll do is if we only did these 2 and the winch was pulling, it would be real easy to turn, right? But with this 3rd one, it gives it that sort of torsion strength. I mean, we'll be pulling underneath it from the center. The spool's only 2 inches or something, or 3 inches maybe, but even still, there's only 2 bolts on the winch, so there's no point in really making any, like 2 of these to kind of try and give it that lateral strength. It doesn't matter. So then we went to the bandsaw and just roughed it out, and again checked our fitment. You know, this just goes in, profile fits real good, everything looks good, it's tight on both 3 holes here, so we can clean it up. One thing I wanted to point out, when you're cutting on the saw, you know, to get radiuses for stress relief, you can see on this one here, there's you know, there's a nice radius here, and all you do, for example, if I wanted to intersect these 2 lines, I just drill a hole right here and then saw cut up to my tangent, and it just leaves sort of a nice finish. And then when you clean it up with your file, it'll look beautiful. So this doesn't need to really look good. You won't see this. It'll be behind the thing, but of course we'll clean it up. We'll take all the saw lines out. We'll round over all the edges. It'll look pretty decent when it's done. So I'll cut the back on the bandsaw, and we'll measure our angle for the bottom, and we could probably just saw cut that, and then we'll start mocking it up to tap our holes. Alright, so we've got our winch assembly done. You can see here the bracket that fits the bumper. All the holes are drilled. Our fair lead plates mounted, and we've gone ahead and screwed it on. And of course we made sure that we can get this in the car with this bolted on prior. And the wires are on, and one thing that I like to do is zip tie the wires to the body of the motor so you're not stressing out the connectors. Of course, if the wire breaks, there's really not much you could do unless you have connectors anyway, but at least the wire, there's no joint there, so it's not as prone to breaking. But let's get it in. Like most winches, the control box, the leads to the control box are real short. Usually you mount the control box on top of the winch or on the side or something like that. But I was actually really disappointed in that. This is a wireless only relay here, so you know that's going to fail, or the battery in the remote's going to go dead. I mean, it's just the stupidest thing. And with these short leads, we could mount it right up behind the bumper here, and it, you know, fits in there almost perfectly, and it would be out of sight, out of mind. But the problem is then as soon as you find your first mud hole or, you know, you get stuck in the sand, this thing or the remote is going to fail, and you're going to have to tear the whole front bumper off. I mean, it's just not going to happen in a trail. So I've cut the wires off of this and off the power wire or off the power supply side, and what I'm going to do is splice just wires onto here that then can run up to the control box that can go, you know, under the hood or somewhere accessible. And when this thing fails, it's not a question of if, it's when. It'll be right there to swap out, or if you're on the trail you can just unhook the wires, you know, I'll put it on a nice terminal block and then just bypass it just right on the trail just with a, you know, 10mm bolt, which turns out there's not a whole lot of them on this car, but we'll try and pick a bolt that there's a bunch of them, maybe an E-socket or Torx or something like that. But just wanted to show how I'm going to solder it. Now it's kind of hacking it because I don't have a soldering iron here that's going to be powerful enough to heat this huge wire. So I have essentially a MAP gas torch, and I did the ground wire here already, and you know, it melts the cable or the shielding or the insulation on the cable a little bit, but you know, I really don't care. This isn't a high dollar thing. And then the only other downside is that with a soldered splice on a wire this thick, it's very stiff here. So this has to be somewhere where it's not going to get bent around or anything like that. I mean, I highly doubt that you're going to be able to break this. What is this? Probably like 8-gauge wire or something like that, or even less or thicker. But anyway, let's just let the camera roll while I'm doing it. Now I found a spec from NASA somewhere saying that 20 times the diameter of the wire and the length of the splice, and then you just essentially put it about halfway and twist them together. And if that's good enough for NASA, that's good enough for me. So even, I guess the spec was saying even without solder, now I did it a little bit short, so 20 times the diameter would probably be something like 1.5 inches here. This is probably only about 1 inch. But what they were saying was even without solder, that splice is going to be stronger than the wire. And I don't see how, but you know, whatever. So this is pretty tight. You know, it looks real nice, but when you start blasting it with the torch, it gets real ugly. But let's let it roll. Got the car off the lift. The bumper, as you've seen, we just threw on. Some of the bolts are in, the hood's back on. Before snapping this piece back on, I just took a coping saw and cut along where I wanted the openings, and then took a real long and coarse file and just filed all of the rubber down just to kind of make it look a little bit smoother. I mean, it doesn't look like a factory edge because of the diamond mesh here. You can actually see, and I'll bring you in where the mesh was, but for what this is, probably looks good at 3 feet, something like that. And if you get closer than that, well, too bad. Also threw in some fog lights. I just used the factory mount, put a flat plate on there, and then screwed it just on into that. I cut this opening fully out because you have to be able to get at the release, otherwise you're going to sit there and unwind 50 foot of cable. I mean, it just doesn't make any sense to heat up your winch like that, and really, you know, with one person you don't want to be doing that. So I just cut out the entire opening. Winch fits in there good, everything's bolted in, everything looks like it should be okay, and the next thing to do is wire it up. In the hood compartment here we have where I did the terminations from when I cut the winch wires. So they run up right to eyes, which used to be on this terminal block. That was the original plan, but of course the controller failed out of the box. It didn't even work. So I just got a normal winch solenoid and hooked it up just like you normally would. Power, ground, and then the 2 wires from the winch, and then your essentially ground forward and reverse, you know, your low power solenoid wires. So the kit that I got essentially is the same kit that is in the 3,500 pound winch from Harbor Freight. So it's the same solenoid, the same sort of, the winch switch goes into here, and you know, then because there's there's actually two switches, one for the handlebar control and then one for the handheld. You have this breakout. So what I'll probably end up doing in the final wiring is, one, I don't need 25 foot before my connector to the thing, so I'll probably end up cutting this real short. And I haven't decided if I just want to leave this in the hood thing there or not. But one thing to point out is you don't need two switches to control the winch, because from this to the driver's side door, you could just put the winch handle or the controller, the handheld can switch right up over the windshield and in the car. That's what I've always done with my Jeeps and everything, so I'm not going to get real fancy and put 3 switches or 2 or whatever. I don't care. And the wireless is totally gone. And good thing that we soldered the wires, because we'd have to tear this whole bumper back off, and just stupid. So, but anyway, the power wires run up right through the firewall. I don't know if you could see it in there. Let me get a light. From the front of the car, I just drilled a hole in the firewall, you can see it in there, and then ran the 2 power wires. And then what I did is I cut an electrical cord, this one, which has 3 pretty decent sized wires. I think it was like 14 gauge or something like that, and that gives me control of things like fog lights or whatever I want to run in there, because I don't feel like drilling 5 more holes. So there's the fog lights run through that, and then whatever other accessory you want, a switched accessory. And then you could see I really put a lot of black silicone on there to kind of keep the wires from chafing and grounding to the body. Looking at under the floor, we've got our battery, normal battery. I've got the ground wire running up. The power wire comes from under the cap, loops around, hits this 50 amp fuse, and then runs up to where I drilled the inside of the hole. And then the same thing, I got a lot of silicone there so the wires don't chafe. Alright, so we've got it buttoned back up. Winch works with the controller or the handheld switch. Everything's good, it sounds good. A couple things I want to point out is reading the instructions or specifications. People online always talk about the width of the spool, and they do that because that decides how much cable you can pull in before it wraps again. And when you wrap onto the second, when the cable lays on itself, you're increasing the radius off the motor, so the pull strength is going to go down. According to this, I can't believe it drops by that much, but according to this, you get 2,500 pounds if you can draw it off your battery for the first 6 foot. So you got to pull the cable all the way out, and then you get 6 feet of 2,500 pounds, and then I think it drops to like 1,100, right? Let me find that information. It goes from 2,500. The next wrap is 2,000, 1,700, 1,500, right? And I don't think there's enough cable to wrap 6 times, but then it says with the winch almost fully in, it can only pull 1,100 pounds. The second thing that I wanted to know is, well, how big of a fuse should I put in this thing? So it comes with a 50 amp circuit breaker. I don't know how that even works. I think I would rather have a fuse. There's no reset on the circuit breaker, so I don't know. So 50 amps. So I was wondering, how much does this thing draw? I just tested, when I took it out of the box, I tested the leads with the cable that I soldered, and it was about 4 ohms. So thinking 12 volts or even 16 volts at 4 ohms, you're only going to be able to draw 4 amps. If I'm doing the math right? 16 over 4 is 4. But according to this chart, if you only draw 4 amps, you're pulling 0 pounds. So this chart, at 12 amp draw, with 0 pounds, 10 amps. at 2,500 pounds, 132 amps. I don't know if a car battery could even support that, let alone an ATV battery. So really, when people put these reviews on this winch, and I've watched a few of them, and basically everybody complains that it's a piece of garbage. But you have to understand the limitations. The motor is only so big, and it can only draw so much. Now, I think what was happening when I measured that was the motor might have been between the contacts. The motor connectors might have been sort of laying on, you know, funny on a brush, or there might have been some grease in the factory. So I just tested it again, and it was lower than the wires on my tester. So that was about 0.3 ohms. So I think it can draw some serious amperage. I'll get a better meter and update that when I do the next video of us testing it. So throw this out. It's probably bullshit anyway, but it kind of gives us a ballpark of where we are. That 50 amp fuse is probably going to have to go to 100 amp, but we'll see. The only thing left to do is get it in the dirt, have another truck there for what if this fails or can't do it, and see what it can do. Watch out for the next video. See you. Thanks for watching.